three equation with three possible roots of g1x, alpha, alpha square and alpha to the power 4. But when we will have this all roots in one set by doing the LCM between g1x and g2x, so we can easily make the fourth equation by replacing or by using the root of alpha cube. Okay, so this is the intention of doing LCM of g1x and g2x, and this is the total topic. So ultimately the minimal polynomials, you can see what is the significance of the minimal polynomials. So this is the minimal polynomials. So these are the minimal polynomials for the GF8, and you can say these are x plus 1 is the minimal polynomial of GF8 of element which consists the element odd which consists the root 1. X cube plus x plus 1 is a minimal polynomial of GF8 which possesses the roots, which possesses the elements alpha, alpha square and alpha 4. This is also the minimal polynomial of GF8 which have the roots alpha cube, alpha 6 and alpha 5. And we have already seen that what is the significance of these roots when we are correcting or detecting the error in the cyclic code. Okay, so I'm just revising it, that when we have to determine one single error, then we need two equations, and we can easily replace alpha and alpha square, and we will get two equations, and from that we will compute the two unknowns, that is the position and the value of the single error. When we'll have two error, that means we need four equations. But considering g1x only, we have three roots, alpha, alpha square and alpha cube. What is our g1x? g1x equals to 1 plus x cube. That means this. So that's why we are doing LCM. We are doing LCM with g1x with g2x. Okay, so that we will have all set of roots. That means alpha, alpha square, alpha 4, alpha 5, alpha 6, alpha 3. All the root will be here. Okay. So that's why we are doing this. Now, the fourth equation, the required fourth equation is this. Okay. And so this is the introduction, leads to more formal definition of the VCH code. So now we have already understood that what is the minimal polynomial, what is the significance of roots by for determining the error, for correcting the error, and we have also used the concept of cyclic code syndrome techniques, and the results we have used, Galois field we have used. So these are all the concepts, and this is the introduction, leads to more formal definition of the VCH code. So in further lecture, in the next lecture, we will enter to the VCH code. Okay, so description of VCH cyclic codes, you can see that this is the description of VCH cyclic code. So we will start. What is the description of VCH code? Okay, and I think you follow the syllabus of this subject. So you can see that minimal polynomial is an important topic, and the very most first topic. Okay, it's the first important topic of this chapter, VCH code, and I will upload this to. I think you will you already have this book, this PDF book. Again, I'm uploading this PDF book again, and also I will upload the PDF, another PDF which I have downloaded. So this is very helpful. And also the handwritten note. Okay, so from this handwritten note, I think this is very important, the advantage and the significance of BCH code. What is the BCH code? So this will be the answer, that in case of cyclic code and linear block code, we are able to correct and detect the singular error bit by the syndrome technique. But in case of BCH code, there we can design for any value of the error correction probability T. Okay, so this is the advantage of BCH code. So that's why we are doing the BCH code. Okay. Right. So lecture is up to this.